the calculus guy.
As we all know, relationships can be rather complicated. You break up, you get back together again. It can all be difficult in a young man's life. Let's say, for example, I'm going out with Jill over here. The more time I spend with Jill, the less time I'll have to be with Tina, my other girlfriend. And what makes matters worse is that they're both related.
I can't believe you stole my boyfriend! Oh, you're such a stupid knave!
That's why learning about related rates can be not only important for math, but even your life in general. Related rates allow us to find the relationship between the rates at which variables such as distance change. Now, don't worry if that sounds a little complicated, because there are 6 easy steps that which you can follow. The first one is to draw a diagram. The second is to write down the rates you know. And the third is to write down the rates that you want to find. After you've done that, the fourth step is to write an equation relating the variables that appear in the rates. The fifth is to differentiate that equation. And finally, the sixth step is to write down the answer. It's simple.
It's a Friday afternoon. School's gotten out and now you're just chillin'. Suddenly, you hear someone approaching from behind. Who could it be, you wonder? But you don't really care because you're too cool to turn around and look. They get closer and closer and you hear their footsteps coming, and then suddenly, there they are. It looks like they're trying to sell you something. Hey, they say, wanna buy some gum? Sure, you love bubble gum, so you hand over some money and you get your gum. They walk away, you start chewing it. And it's bubble gum too. Gee, you love bubble gum. But as you sit there and chew your bubble gum, you wonder about what you've been studying lately in calculus and related rates, and how it could possibly pertain to your bubble gum blowing experience. So let's just say that by your amazing powers of observation, you've been able to deduce that the rate at which the radius of your sphere of bubblegum is changing is 0.5 centimeters per second. So now, let's say that you want to find out at what rate the volume of your sphere of bubblegum is changing when the radius is at a specific point. And in this case, we'll use 15 centimeters. So, what you first do is draw a diagram, and then write out what you know and what you're trying to find. So what you know is dr dt, which is the rate at which the radius is changing, and that is 0.5 centimeters per second. And then dv dt is what you're trying to find, and in this case it's when r equals 15. So to proceed from there, you want to find an equation you can use. And in this case, the equation will be the volume of a sphere equation, which, as you will recall from geometry, is the volume equals 4/3 pi times r cubed. So now what you're going to do is differentiate both sides of that equation, because that's where the calculus aspect of this kicks in. So you get dv dt equals 4 pi r squared times dr dt. And if you don't know how we got from there to there, you just go back and re-examine the exponent rule, which is as follows. So then after that, all you have to do is plug in the values that you know, and from there it's just extremely straightforward, because you know that r equals 15 and that dr dt equals 0.5. So plug them in and then just multiply through and you have your answer. And so in this case, the answer is dv dt equals 450 pi centimeters cubed per second, and that is how fast the volume is changing. So now you can see how helpful calculus is in helping you solve a problem that you have surely been pondering every time you sit down to blow a sphere of bubblegum.
I just got back from the gun carnival, and I was really sweaty from the bouncy house. So, I decided to go home and take a bath. I was getting ready to get in when suddenly, to my horror, I saw a large colony of bacteria. I was hecka creeped out, so I got the heck out of there. Later, I was feeling pensive, so I decided to figure out at what rate the bacteria would expand. Here's the problem. Because I love calculus so much, I already figured out the rate at which the area of the colony is changing with respect to time. So what I really want to find out now is the rate at which the radius of the bacteria colony is changing with respect to time. And to do that, we're going to follow Bill Rye's 6-step explanation to tackle a problem. So first, we're going to draw the diagram. And my lovely assistant, Jill, who is also my sister and Bill Rye's ex-girlfriend, drew a diagram for me already. So before, we have the bathtub with a little colony, and there's me, scared. And then here we have after the bacteria has grown after a while, there's me dead, there's lots more bacteria. Step 2, what we know. So we want to state what we know so we get all that cleared out. What we know is dAdt, which is the rate at which the area is changing with respect to time, equals 12. And from past geometry classes, we know that area equals pi radius squared, pi r squared. Step 3, state what we want to know. What are we trying to find here? We're trying to find the rate at which the radius of the bacteria colony is changing with respect to time, which is dr dt. Step 4, write the equation. So the equation is dA over dAdt equals 2 pi r times dr dt, which is what we want to know. Let's move on to step 5, which is solving the problem. So from problem 4, we have dAdt equals 2 pi r dr dt. So from the givens, we know that dAdt equals 12. So we can plug in 12 into this equation and get 12 equals 2 pi r times dr dt. So after we've done some algebra, we can figure out the general equation, which is 6 over pi r equals dr over dt. That's what we wanted to find. Not a big deal. All we did was some algebra. It's okay. So this is our general equation. And if we wanted to find the rate at which another radius is changing, like any radius that the circle of bacteria is changing at, all we can do is we say, let's try radius equals 3 millimeters. So here we would plug in 3 into the general equation, and we would say 6 over pi times 3 equals dr dt. And then after we do some more algebra, we can figure out that dr over dt equals 2 over pi, when the radius equals 3 millimeters. So then we can move on to step 6, which is where we state our answer. And our answer is the rate at which the radius is changing with respect to time equals 2 over pi. Not a big deal, and that's your answer.
To conclude our program today, my lab assistant Jill, and now my ex-girlfriend, will give a few final words.
So we've shown you the 6 easy steps to solve any related rates problem. We've taken you to the path and we've taken you to the bath, and so now you can all see how math and related rates relates to everyday life. Thanks for watching!